Hello, my name is Cecil, and today I'm going to be walking you through a Physics 211 problem. In this problem, we're going to be focusing on Chapter 4 concepts, and we're going to be working with a constant acceleration without being given a time. In this problem, a rover on Mars launches off a cliff from a 15-degree incline while traveling at 12 meters per second. Assuming that the height of the cliff is 38 meters, find the time that the rover was in the air and the horizontal distance that it traveled before it reached the ground. In order to do anything, first I want to make a drawing of exactly what's happening. I'm going to make another diagram. So if we look, we're going to see that the degree that V0 is from being on the level ground is going to be 15 degrees because of the 15-degree incline, which we'll call theta. So if we want to find the x and the y components of the velocity, then Vx will be equal to 12 meters over seconds, or V0, multiplied by cosine of theta, which is 15 degrees, and Vy will be equal to 12 meters over seconds, multiplied by sine of 15 degrees, or theta. So if we just write this at the bottom, then Vy is going to be equal to 12 meters over seconds multiplied by sine of 15 degrees, or 3.106 meters over seconds. The V0 in the x direction is going to be equal to 12 meters over seconds multiplied by cosine of 15 degrees, or 11.59 meters over seconds. We know that the acceleration in the y direction, or the gravitational acceleration on Mars, by looking at outside resources, we can see that this is going to be equal to 3.71 meters over seconds. So then, using the information we have, we're going to be able to actually solve for it. If we say that the top of the hill is y equals 0, then the y position is going to be equal to V0 in the y direction multiplied by t plus 1/2 of the acceleration in the y direction multiplied by t squared. Then we also know that the height of the cliff is 38 meters, so when y is equal to negative 38 meters, it's going to be at the bottom of the cliff. So we can plug in y equals negative 38 meters, as well as the other two things we know, which is that V0y is equal to 3.106 meters over seconds, and that the acceleration is equal to 3.71 meters over second squared. We can plug in all of these, and then we'll be able to solve for t, or the time. It's worth noting that the reason that the acceleration in the y direction is negative is because it's in the opposite direction of our supposed positive direction. So basically I'm following standard conventions and saying that this is the positive direction, this is the negative direction, positive, negative. We can say that negative 38 meters is equal to 3.106 times t minus 1/2 negative 3.71 meters over second squared t squared. So now I'm going to want to simplify. I also meant to say plus. So now I'm going to want to simplify, and if I simplify, then I'm going to have just negative 38 meters is equal to 3.106 meters over seconds t minus 1.855 meters over second squared t squared. Now we're going to want to put everything to one side. I want to get rid of this negative value here, and in order to do so, I'm going to have to add everything over to the left side. So then we're going to have 1.855 meters over second squared t squared minus 3.106 meters over seconds multiplied by t minus 38 meters is equal to 0. Now we're going to be able to use the quadratic formula in order to further solve it. We can then say that a is equal to 1.855, b is equal to 3.106, and c is equal to negative 38. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a is going to be equal to our two possible time values. It's important to note that any negative t value or time value is not possible since it's saying that it happened before we were observing what was happening. So negative b, so negative 3.106 plus minus the square root of negative 3.106 squared minus 4 times 1.855 times negative 38 over 2 times 1.855. If we plug some of this into the calculator and simplify a bit, then we're going to get that 3.106 plus or minus 17.07, all divided by 3.71 is going to be equal to our possible t values. Now, as I said before, we cannot have a negative t value, so we can assume that 3 minus roughly 17 will give a negative value, so we don't need to look at that one. And we just need to look at the additive one. So 3.106 plus 17.07 is going to be equal to 20.116. And then that's going to be divided by 3.71. So it'll be equal to 5.44 seconds. So that's our final answer for the first part. T is equal to 5.44 seconds. So the rover was in air or falling for 5.44 seconds. The x position is equal to v naught in the x direction multiplied by t plus 1/2 of a in the x direction times t squared. And so x is then is equal to, we know v naught in the x direction is 11.59 meters over seconds multiplied by t, which is 5.44 seconds, plus 1/2 a in the x direction. Well, we have no force acting on it, so there's no acceleration, so that's just 0, multiplied by 5.44 seconds squared. This will all just cancel off and be 0, so x is going to be equal to 11.59 meters over seconds multiplied by 5.44 seconds. X is equal to 63.05 meters. The rover traveled 63.05 meters while falling. So I hope this was helpful, and I will see you in the next one. Have a great day.